Okay, we're going to have a look at the nucleophilic substitution mechanism, starting off with the hydrolysis, which will be with a hydroxide ion. Lone pair on the oxygen, don't forget. Nice easy example to start with, so bromomethane. So when we draw this, just make the carbon which we're going to attack, so the electron deficient carbon, make that nice and accessible to the nucleophile. So just pop that there, and then the arrow's coming in. So what we're looking for is the arrow to finish just around about there, sort of getting towards the carbon. And at the same time that that happens, then the carbon-bromine bond is going to break. Both of those electrons go into the bromine because the bromine, remember, is more electronegative. So what will that make? So the oxygen is now bonded to the carbon, and we've kicked out the bromine in the form of a bromide ion. The mechanism, as all of these will be, is nucleophilic substitution. Right, slightly more difficult maybe, 1-chloropropane. So we need to get the organic starting material right. So that's the chlorine that we're going to, that's the carbon that we're going to attach, which is on the first carbon. And we've got 2 more carbons in the chain, which I'm just going to write like that, just to make the emphasis of this mechanism, this electron deficient carbon. Doesn't really matter where the hydroxide goes this time. I'm going to pop it down there. Remember the negative charge. And then it's arrow coming in, kicking the chlorine out. What will that make? Our alcohol now slightly longer. We've got 3 carbons in the chain. And the hydroxyl group is on the first carbon, making this propan-1-ol. And again, we have a halide ion which we've generated. In this case, it's the chloride. Nucleophilic substitution again. Final example, probably the more difficult of the 3, is for 2-iodobutane. Again, just need to make sure that we draw the right structure. Again, making it easy to get to the electron deficient carbon. Not bothered putting the partial charges in this time. You won't need to do that. There's our alcohol, and we've also got the iodide ion. Just pause the screen and see if you can work out what the alcohol is that we've made. So very well done if you got butan-2-ol. So hopefully we can see that the OH group is attached to the second carbon in a chain of 4. So butan-2-ol, and again it's a nucleophilic substitution reaction.